Okay, the first thing you need to be able to do is identify when a sequence is linear, quadratic or cubic. There are other types of sequences as well, for instance geometric or some kind of Fibonacci sequence, but for the regression tool these are the three things we can work out the nth term of. So linear sequences have a constant first difference, I'll come on to that in a sec. Quadratic sequences have a constant second difference. Cubic sequences have a constant third difference, and just to identify if they're linear, quadratic or cubic, that is all you need to know. So let's go on to the first sequence, which was -1, 3, 7, 11, 15, 19. So the difference means what do I need to do to get from one number to the next. So from -1 to 3 is +4. Now if you couldn't work that out easily, you could just do 3 minus -1. But if you look here, 7 minus 3 is also +4. 7 to 11 +4, +4, +4, +4. That has a constant, this is the first difference, constant first difference. So that tells us sequence is linear. Which means the nth term will look like this, an plus b. It'll be that kind, it will be that form, and then we just have to find a and b. Right, the second sequence, -3.5, 1, 6.5, 13, 20.5 and 29. Now these are a bit more tricky, but remember, if you're not sure, just do 1 minus -3.5, that's 4.5 and it's positive. 6.5 minus 1 is 5.5, so 13 minus 6.5 is 6.5, so plus 6.5, and 13 to 20.5 is plus 7.5. You should see a nice pattern going on, plus 8.5. So if you see a pattern in the first differences, it's because they have a constant second difference. This is +1, +1, +1, +1 and +1, constant second difference of 1. So that means two things. It means sequence is quadratic, so it means un is going to be in the form an squared plus bn plus c. Right, so the third sequence is a bit of a nasty one, but because, I mean, this is a calculator module anyway, so you're allowed a calculator, so we're going to work out some differences. Now, -3 minus 16 is -19. -64 minus 3 is -61. Gets a bit tricky after that, so I am going to use a calculator. So you got -127. -217 minus 331. Okay, the second difference. So that was the first difference. There's definitely no pattern so far. Second difference is, so -61 minus -19 is -42. -127 minus -61 is -66. And then we carry on -90. And -114, and then if we take the differences between the second differences, you should end up with -66 minus 42 is -24, as is -90 minus -66 -24, as is -114 minus -90 -24. So we have a constant third difference. Constant third difference, which tells us the sequence is cubic. Sequence is cubic, which means the un will be in the form an cubed plus bn squared plus cn plus d. Right, so now we just have to use the calculator to actually work them out. Okay, now we've established that the first sequence is linear, the second sequence is quadratic, and the third sequence is cubic. we're now going to use the regression technology in the calculator to actually calculate these nth terms for us. So the first one is minus 1, 3, 7, 11, 15, 19. We know it had a constant first difference. We know it's linear. Now, for any of these, you're going to go to the same place, and it's menu, and it's statistics. So number 2 for statistics. And you get this list 1, list 2. So what you do, list 1 is n. It's the number, the term number. So there's 6 numbers, 6 terms in the sequence. So this first column is just going to be 1, 2, 3, 4, 5, 6. Just like that. And then the second column is going to be the actual sequence. So when n is 1, the term is minus 1, because that's the first term in the sequence. So then your numbers are 3, 7, 11, 15, and 19. So that's the stat bit ready. Now you're ready for the calculation. So you go to calc for calculation. So you're going to press F2, and this is reg for regression. You'll do more about regression later. So reg, like that. And because we know it's linear, we're on this X regression. So we press X, and we want AX plus B. So there you go. And it's told us that if y equaled ax plus b, a is 4 and b is minus 5, which means if un equals an plus b, well, that's going to be 4n minus 5, as we thought that it probably should be. Okay, now on to the second sequence. So you're going to go back to the menu and back to statistics. So 2 for statistics. If you're in a bit you don't like, just press exit. And then we need to go back up here, and we need to change the numbers again. Now, if you were coming in having not just done a sequence question, you'd probably have to delete both of these. In this case, because I've just used the calculator to calculate the nth term of a sequence, the first column is absolutely fine, 1, 2, 3, 4, 5, and 6. The second column, I need to now change the sequence terms for it. So for the second sequence, it is minus 3.5. 1, 6.5, 13, 20.5, and 29. Just like that. So that is finished. And it's on this that if you don't like something, just press exit is a really good button. It kind of gets you back to original screen. So we were a couple of layers in then we didn't want to be. So if you just come in fresh, you're likely to be on this screen again. So you're going to press calc, and you're going to press reg for regression. And because I know this is quadratic, I know this sequence has a constant second difference. So I want to be on this x squared regression. So x squared. So that is telling me if y equals ax squared plus bx plus c, well, a is 0.5, b is 3, and c is minus 7. So remember, we don't have x's, we have n's, and we don't have y's, we have un's. So un equals 0.5n squared plus 3n minus 7. Okay, now for the third and final sequence. So you're going to go back into menu and back into the statistics mode. And again, fortunately, we already have this 1, 2, 3, 4, 5, and 6. If you didn't, you would put it in. So now I need to put the actual sequence on the right-hand side. The third sequence was, the first time was 16, minus 3, minus 64. You do need to be really careful with that. It sounds obvious, but if you mess up one sign, one number, anything, if you miss a number, you're going to ruin everything and get a completely wrong answer. So do be careful. Minus 191, minus 408, and minus 739. Just like that. Calc, reg for regression, and I know this sequence has a constant third difference, which means it's cubic, so I want the x cubed regression like that. Now, this is a bit different. It does happen on the Casios. It's not so bad on the TIs actually, but you've got a lot of rolling lines and you've got this standard form thing, so I'll try and translate that. So it's saying, if I just go down a bit, y equals ax cubed plus bx squared plus cx plus d, which means, remember, in our case, un equals an cubed plus bn squared plus cn plus d. So if we go back, a, it says, is minus 3.999999. A is minus 4. This will happen quite often when you're doing this exact task. Just round that. One significant figure in this case. So A equals minus 4. B equals 3. C is a bit tougher. This is saying 3.25 times 10 to the power minus 10. If you know your standard form, you will know that gives you a very, very small number indeed. It's going to be 10 zeros and then 325. C is 0. It's just it's the rounding thing, because you only actually have 6 numbers. You probably need more numbers to do it really accurate in a calculator. But anyway, C is 0 and D is 17. So UN for this would be minus 4n cubed plus 3n squared plus 17. So there's no C, there's no x term.